Kia ora everyone, welcome to the second module relating to the introduction to risk analysis prepared for the Pacific Island countries. So the first module we delivered was just an overview of MPI, or the Ministry for Primary Industries here in New Zealand, and just some of the risk analysis work that's taking place in the Animal Health and the Food Safety Directorates. The second module here is going to be looking a little bit more deeply at the concepts around risk analysis. We're going to be having a bit of a better look at the definitions themselves, and so I hope you enjoy this next module. If we can get it moving along. So the things we're going to be talking about today, we're just going to be talking about some of the definitions used in risk analysis, and we will have a look at the website with the OAE where some of these definitions are taken from. In fact, all these concepts of risk analysis are taken from the OAE, and New Zealand has been heavily involved in helping develop the risk analysis framework that the OAE and WHO have put out. We'll look at the concept of risk. We'll look at the kinds of questions. Again, I know some of this repeated from the first module, but we will have a look at those particular questions that we are trying to answer from a risk analysis perspective. We will look at the components of risk assessment in a little bit more detail again, and talk a little bit about some of the terminology or some of the definitions that are probably a little bit more difficult to understand, and then dive a little bit into the qualitative versus the quantitative risk assessment, and then followed or ending with the appropriate level of protection. So before we whip into the definitions, I just want to quickly pull across a few websites I just want you to be aware of. So the first is the World Organization for Animal Health. What we have here is what's called the Terrestrial Animal Health Code. So the majority of countries' risk analysis programs have been developed utilizing information provided within this particular code. It has different iterations each year, but only very minor changes. Because this information has been established for many years now, and it is continuing to be found to be very robust. So when we look at the Animal Health Code, I just want to point out the glossary. It loads it up. And so in the glossary, it's got a definition of all the different types of wording or criteria that we use in the risk analysis. And as an example, if you pop down to definition of hazard, here we have definition of hazard means a biological, chemical, physical agent in, etc. Now these definitions that we have here are exactly what we're going to be using today in the module. So we'll go back to open up my presentation again so I can see it. Okay, so let's have a quick look at some of the key definitions. So hazard is a biological, chemical or physical agent in or a condition in an animal or animal product with the potential to cause an adverse ill effect. So the hazard definition is exactly the same as what you would use for developing a HACCP system or a HACCP plan in the likes of a risk management program, a full food control plan, or looking to manage hazards associated with food. Risk is a product of the likelihood of the occurrence and the likely magnitude of the biological and economic consequences of an adverse event or effect to an animal or human health. And we use the example of an individual hopping into their vehicle and the types of risks or hazards and associated risks with actually going for a drive, and the kind of considerations that a driver needs to make when hopping into their vehicle and going for a long journey. We have a risk analysis, the process composed of hazard identification, risk assessment, risk management and risk communication. Again, we covered this off last week, but we're going to reiterate a few of these points today. Risk assessment, probably one of the most pertinent parts of the risk analysis, is the evaluation of the likelihood and the biological and economic consequences of entry, establishment and spread of a hazard, and we will use a specific example, a couple of examples today when talking about what a risk assessment might actually look like. Qualitative risk assessment, an assessment where the outputs on the likelihood of the outcome or the magnitude of the consequences are expressed in qualitative terms such as high, medium, low or negligible. And we mentioned last week, and in this module we will reiterate it again, that the qualitative risk assessment is probably the most important and most frequent type of risk assessment compared to the quantitative risk assessment. And a quantitative risk assessment is an assessment where the outputs of the risk assessment are expressed numerically, and we'll talk about some examples later on in that space. Again, all taken from the Terrestrial Animal Health Code found on the OAE website 2019. We'll get this working again if it works. So what is risk? Again, it's the likelihood of an event occurring and the consequences or the impact of the event, and we express this in a qualitative and a quantitative manner. Risk analysis must answer the following questions: what can go wrong? How likely is it to go wrong? What are the consequences of it going wrong? And what can be done to reduce the likelihood or the consequences of it going wrong? So sticking to our car analogy last week, when we are carrying out a risk analysis, subconsciously every time we hop into a vehicle and go for a drive, I guess are answering the question or asking the question, what can go wrong? We know we can get a speeding ticket, we know we can crash, we know we can get a flat tyre, something can go wrong in the vehicle, but we don't always focus on those things. But how likely is it to go wrong? Well, every time I hop into my vehicle, I know I'm probably more than likely to get a flat tyre rather than actually be involved in a car accident, or those things where we are assessing the hazards and the risks associated with those hazards. What are the consequences of it going wrong? Again, we talk about in the car journey example, the likelihood of being involved in a car crash is very low. What are the consequences, however, of being in a car crash? We talk about certain scenarios involving the driver, involving the passengers in the vehicle, and involving other passengers and other vehicles or pedestrians, and what can be done to reduce the likelihood or the consequence of it going wrong. Obviously, you buy a Holden or a Toyota to reduce the likelihood of something going wrong. But in the vehicle example, these are the kinds of assessments you're making when you're looking to purchase a vehicle or taking advanced driver training, or looking to keep within the speed limit to reduce the likelihood or the consequences of a car crash, for example, taking place. So 4 components of the risk analysis. Again, hazard identification. The hazard identification, even though it's a very laborious process, the hazard identification is probably the piece of information that is most available in research, and so certainly one of the, I wouldn't say the easier parts of the risk analysis, but is certainly the one where the most amount of information is available. This is where your epidemiologists become incredibly useful, particularly around pathway assessment. Your risk assessment itself, this is where it becomes a bit more complicated, and obviously risk management is where you're assessing the options for managing the risk and making a decision based on all the information that you have available from an economic, a human health, animal health, social, international trade policy perspective, and using that information to make a decision around how you're going to manage those specific risks. And obviously at each part of those processes you are communicating with the right individuals around the steps you are taking, or the research you are undertaking for carrying out the risk analysis itself. We briefly touched on the pathway. Again, this is out of the Terrestrial Animal Health Code, but it's very, very useful if you are a risk analyst or risk assessor or risk manager. This kind of pathway diagram is really useful for having up on your wall, just to remind you about the expectations with the pathway assessment, for identifying what the hazard is, providing characteristics of the particular hazard, and then undertaking a risk assessment itself. So hazard, we pointed out the OAE website with the Terrestrial Animal Health Code. So again, this is taken directly from that page or from the glossary within the Animal Health Code or the Terrestrial Animal Health Code. Hazard is a biological, chemical, physical agent in an animal or an animal product with the potential to cause an adverse ill effect. So countries around the world, for example, are looking at the biological agent of African swine fever in pork products and asking the question, does this actually have the potential to cause an adverse ill effect on a human or an animal? If so, how do we manage those specific hazards? So that's a good example, or a very a timely example of the kinds of discussions that are taking place internationally at the current time. We're talking about the 4 components of risk assessment, and again, this is where pathway development becomes incredibly important. And I'm not going to go back through the pathway examples that we put up in last week's module, but there is quite an extensive assessment taking place from a pathway perspective, trying to assess the probability of the entry of a hazard, and where we describe the biological pathways necessary to introduce a hazard into a country or a population, and so we look at the types of transportation or entry pathways for that hazard actually get into a country in the first place. And we talked about types of plants, types of animals, the types of containers, the transportation opportunities, and how that hazard itself is actually able to enter a country. We talked about the exposure assessment. So what is the probability of exposure? And we described the biological pathways necessary for the exposure of that hazard to an animal or humans in the importing country. So we talked about, for example, Listeria monocytogenes in a ready-to-eat product. What are the biological pathways required for that Listeria monocytogenes strain to go from the product or the animal product and to be consumed by a human and cause an adverse health effect. We talked about the consequences, or the magnitude of those consequences, should an animal or a human be exposed to a particular hazard and suffer consequences from that particular hazard. So we describe the potential biological and economical consequences of a given exposure, and again we'll use some examples a little bit later on. And we talked about risk estimation, so where we look at the overall categorization of the entry assessment, the exposure assessment and the consequence assessment to produce an overall measure of risk associated with the hazards identified, and that allows us to come up with a very robust, largely qualitative assessment, but a quantitative assessment is required to enable risk management options to be developed if required, and to enable a manager to assess the size of that risk, or to decide which option is most appropriate for managing those risks in line with risk estimation itself. So for the 4 components of risk assessment, again using the African swine fever as a really good example. When we describe the biological pathways necessary to introduce the hazard, so here we have a diagram of Polynesia, the Micronesia nations and the Melanesia nations, because the module is for the Pacific Island countries. We can ask the question when undertaking an entry assessment, what is the probability or the likelihood that a piece of pork, whether it be raw or cooked, or in a ready-to-eat manner, chilled or frozen, what are the pathways required to introduce that African swine fever on that piece of meat into those specific countries? And that's obviously probably one of the most critical parts of the risk assessment, because it actually allows you to see what size or the kind of biological border controls that are required to minimise, as well as the pre-export controls required to minimise the possibility of that hazard actually entering your country. We talked about an exposure assessment, so what is the probability of exposure? So when we describe the necessary pathways for exposure of the animals and humans in the importing country, and here we have Tonga as an example, and we're utilising one of my wonderful colleagues, Tiaki, in this example. What is the pathway that would be required for an African swine fever organism to be able to infect a human or an animal, or ensure that they're actually exposed to that organism within the country itself. So some of those things that we consider aerosol. So what is the opportunities provided for an organism to move in aerosol, whether it be droplets in the wind. I know foot and mouth disease is a pretty tragic disease that has a very high likelihood of spread via the aerosol means. But what is the likelihood of African swine fever being able to infect humans or animals using the aerosol method? Consumption, so what is the likelihood or biological pathways for a human or an animal to be infected with African swine fever through consuming either cooked or uncooked meat. And this is where we need to consider the likes of raw meat scrap. So quite common for a lot of individuals in New Zealand and the Pacific Island countries to have pigs in the backyard, particularly on our lifestyle blocks, where we may inadvertently put some raw meat into the scrap bucket for a pig to then consume. And that is a possible biological pathway that needs to be considered when looking at the likes of organisms such as African swine fever. So there's commercial piggery and backyard considerations, but also fomite transfer. So when you have equipment that veterinarians, for example, are using when they are undertaking specific assessments, might be reproductive assessments in a piggery, a commercial piggery, or through vehicles, through clothing, what are the possible pathways by which African swine fever could be spread on those particular fomites? And tools are a particularly important method of transfer as transportation. So we look at the consequence. So when we look at or assess the consequence of should an African swine fever enter a country, should an animal or human be exposed to that organism, and what are the consequences health-wise or economic-wise or economy-wise, there we go, should that African swine fever then have an impact on animal or human health. And in this specific example, we would say that the likelihood or the consequences are very low for a biological impact on a human being, because African swine fever is quite specific to pigs, and they have very little if no impact from a food safety perspective on human beings. But the biological consequences are very, very significant when it comes to domestic and commercial piggeries. A very, very high mortality rate, and cures are very, very difficult to find and to implement within the piggeries. So we say that the biological consequences are very significant in the animal health population or the animal population. So when we look at it from an economical consequence perspective, commercial piggeries, those that are relying on subsistence farming with their piggery, backyard piggeries, are going to be severely impacted, and that ultimately is going to have an impact on the human population, because reducing meat sources domestically means that they're going to be spending more money on importing products, or having to turn to alternative products to meet their protein needs, and that is a supply and demand outcome. So the consequences from an economical perspective become very high when considering the consequences of African swine fever entering the country, becoming established and wreaking havoc. So the risk management is the process of identifying, selecting and implementing measures that can be applied to reduce the level of risk. So here we have, again, the risk assessors will provide a variety of options. They may provide one option, they may provide 3 or 4 or 5 different options to the risk manager, with varying levels of management criteria that the risk manager can then assess and make decisions on, again using those earlier criteria that we discussed from an animal and human health perspective, a social perspective, economical perspective, as well as trading or international obligation requirements. And finally, at those different levels, we also have risk communication. So as we've noted here, this is the interactive transmission and exchange of information and opinions throughout the risk analysis process concerning the risk-related factors, risk perceptions among risk assessors, risk managers, risk communicators, the general public, and other interested parties. So for example, in the space when we consider the general public and we talk about risk perceptions, a risk assessor or a risk manager may consider a particular organism or the risk assessment to be low in terms of its impact, but if the general public itself believes or have a perception that the risk is very, very high, the risk manager needs to take that into consideration. It doesn't become the overall requirement or rationale behind a decision that is made, but it certainly needs to be considered. And the reason why this is considered is, number one, so during the risk assessment process, those concerns can be effectively managed through a communication strategy, but also it means if a particular risk option is going to be implemented that could be upsetting to the general public, a communication strategy can be implemented then as well to minimise concerns amongst the general public. Other interested parties, there are always international researchers and risk assessors, government bodies. They'll always be interested in the work that has been undertaken in the risk assessment space, particularly if it's a new piece of work that is going to have a global impact or produce information that is going to be utilised by other risk assessors and risk managers in other jurisdictions. If we can get through it. So risk communication. So from a risk communication perspective, I've just got a diagram here that we use in our supply chain integrity program to ensure that individuals undertaking a risk assessment or the risk analysis as a whole can ensure that they're actually looking at the type of individuals who may be impacted by any management decision that is made relating to managing those risks, and ensuring that communication is going to be appropriate for the type of impact for that particular stakeholder or partner. So we've got a few individuals or few groups here I just want to highlight. Farmers, obviously farmers are normally always the first individuals, farmers or orchardists, normally always the first groups or individuals who are most impacted by decisions that have been made around implementing risk management options or risk management decisions. Number one, because of the specific livelihood of those farmers, but number two, because of the costs that could be associated with trying to impose specific risk management options or trying to have quite relaxed risk management options, and ensuring that they're aware of their role that they need to play should a specific risk management option have its downsides. And the reality is many management decisions that are made will have disadvantages, and they just need to be effectively managed. In this example, we've also included there Māori. Now, Māori have a very strong affinity to land, being the indigenous people of New Zealand, as an example, and we need to take into consideration the cultural aspects or cultural needs in line with the Treaty of Waitangi and our obligations as a government organisation to effectively communicate with our Māori partners to ensure that any decisions that we make are going to be done in conjunction or in consideration with their expectations, their needs, and that they actually have an input into the decision-making process where required. So on the qualitative risk assessment, so we talked early on about the qualitative versus quantitative risk assessment, and we talked about it being a very reasoned and logical discussion, and I've noted here, or just included from our guidance material, where the outputs on the likelihood of the outcome or the magnitude of the consequences are expressed in qualitative terms, such as high, medium, low or negligible. For example, we come back to our example from last week, Listeria monocytogenes. So in the raw uncooked beef that a country might be importing, the likelihood of the outcome or the magnitude of consequence for raw uncooked beef, where you know that beef is likely to be cooked, is going to be very low or even negligible. For example, where you've got a piece of steak that you know is going to be cooked on the barbecue, or even uncooked beef where you know it's going to be used for mincemeat and burger patties and going to be thoroughly cooked, the likelihood of having Listeria monocytogenes or the consequence of it entering and spreading through the population is going to be incredibly low. Also largely because Listeria monocytogenes is a very ubiquitous organism. In other words, it is pretty much everywhere. There is not a single country in the world that does not have it, and so controls are already reasonably adequate. If we compare this to the likes of raw milk cheese, so this is just simply cheese made from milk which has been unpasteurised, and in recent years New Zealand has started permitting the importation of raw milk cheese. The likelihood or the consequence of Listeria monocytogenes on raw milk cheese are significantly higher than pasteurised cheese or pasteurised milk cheese, and therefore the criteria that we impose on exporting countries as well as our domestic stakeholders processing that particular type of cheese is going to be very, very high to minimise the impact on our consumers. Try to get this thing to work. Come on, right. And as we noted earlier on, the qualitative approach or qualitative risk assessment is probably widely used for the majority of our import risk analysis because it is easy to understand, easy to explain from a negligible, low, medium, high perspective, and is currently the most common type of assessment undertaken to support routine import decision making. It's the same using our driving example. When I hop into my vehicle, I say, well, the likelihood of me having a crash is low. I don't make a quantitative assessment saying the likelihood of me having a crash is 0.036, and therefore that will determine whether or not I'm going to wear a seatbelt or keep to the speed limit. So qualitative risk assessment is the most appropriate for most import risk assessments. However, when it comes to quantitative risk assessments, and we know it's a numerical expression of a risk assessment, this involves developing a mathematical model to link the steps of the risk pathway, which are expressed numerically. And we've noted it may be desirable to undertake a quantitative analysis as an adjunct to a qualitative risk assessment. So this is where a qualitative risk assessment may still be a little bit inconclusive, or a manager may wish a quantitative risk assessment to take place to help with decision making around the types of options or the impact on animal or human health. And a really good example we have here, we had a container ship partly capsized off the Bay of Plenty coast in New Zealand, and an assessment or quantitative risk assessment was undertaken to look at the likelihood of particular contaminants from the ship entering the waterways or entering the ocean and possibly impacting sea life. Knowing that the sea life, the aquatic species were going to be consumed or harvested, they wanted to look at the possibility of those contaminants making their way into the sea life and what the impact on consuming those particular seafood was actually going to be on the human health. So this looked at the things like oil contaminants, a very complicated pathway, but something done by New Zealand Food Safety Directorate here in MPI to enable the local and central government to make decisions around whether or not they impose bans on harvesting shellfish or taking seafood, and for how long. So we talk about transparency, and I'll flick over to a website in a few moments, but there are three particular terms that we need to understand. First one being transparency. This is a comprehensive documentation of all data, information, assumptions, methods, results, discussion and conclusions used in the risk analysis. And I've noted there that conclusions should be supported by an objective and logical discussion, and documents must be fully referenced. And so we'll, in future modules, we will use a few examples in the space, and we will show what the risk analysis document has actually detailed regarding a particular risk organism, and how it's actually been established in the document, and references that are generally called upon to help make the risk analysis or risk assessment itself. So the reason for this is to enable, not just the only reason, but one of the main reasons for this is to allow any affected party, whether it be domestic or international, to challenge or consider the types of conclusions that have been gathered from the reference material. But also allows other countries, when they're undertaking their own assessment, to look at the rationale behind decisions, to reference back or look back at the specific journals which have been referenced or considered when making a risk management decision, and they can either challenge that or look to agree with that particular outcome or particular finding within the risk analysis itself, and utilise it for their own purposes, or challenge it to request that the importing country carry out further review. This is really important when an import risk analysis mandates control methods at pre-export stage. So an exporter wanting to export products to New Zealand, if a management or a risk management option has been determined, that means that the requirements of the exporter and the exporting country is going to be very onerous or very costly, including to government, and they believe it's inappropriate or unfair even, they have an opportunity to challenge those things. We also have uncertainty. So this is about the quality of data being unknown. For example, the data that exists are inadequate or incomplete, or because of biological phenomena involved and not well not understood, or the pathways themselves are not fully understood. We'll note there's some incomplete knowledge or a lack of understanding of a pathogen, which is the knowledge itself becomes more complete, and you have greater understanding the further down the track you're examining or trying to obtain information or more data. And a really good example in the current times is COVID-19. So this specific coronavirus is not well understood. There's a significant amount of uncertainty at the initial outbreak, but as scientists have been able to look at the epidemiological nature of the organism, they've been able to obtain more data, and then that uncertainty is becoming less and less over time. And finally, the variability. Now, this is the natural heterogeneity inherent in any biological system. So a really good example, I've just noted there, it's a characteristic of phenomena that differs from one observation to another. Again, this is all from the OAE website and other documents that MPI utilises, so none of this should be different to what we're seeing internationally. But a really good example of this is food consumption data, where you know the consumption activities or behaviours can be very, very different from one part of the country to the next. We have very different eating habits, for example, in Auckland versus what we see at the bottom of the South Island, Dunedin. Now, the reason why this is really important is because variability can have an impact on the likes of exposure, assessment, understanding, and ultimately the consequences of the entry and exposure of that particular organism itself. So variability is important to understand, and variability needs to be effectively demonstrated or written up within the final risk analysis, import risk analysis document around what considerations were given when coming to a specific risk management option or decision. Now, if we go back to our website, Under the FAO website, we have again some more information around uncertainty and variability in the risk assessment process. I'm not going to go through this in detail. What we are going to do at a later date is get a specialist on board to talk about this in a bit more detail and use some working examples of where uncertainty and variability have had to be effectively communicated and have possibly had an impact on decisions that have been made by the risk managers. So I'm not going to go through in detail again, but this is certainly here to consider. Right, so finally, start again. No, not going to work. Apologies. Finally, we talk about our appropriate level of protection. So under the World Trade Organization Sanitary and Phytosanitary Measure Agreement, members are entitled to maintain a level of protection that they consider appropriate to protect life or health within their territory, within reason. So this quite often is already associated with the level of diseases or a number of diseases and the level of spread of a specific disease within their own country, what kind of economic consequence or animal or human health consequences that a particular country is willing to accept within the guidelines that the WTO have already established. So again, we just pull this into. So we have a look at the World Trade Organization guidelines. Again, another really great website to consider when developing sanitary phytosanitary measures and their impact on import house standard development. If we come down to the SPS agreement, while permitting governments to maintain appropriate sanitary and phytosanitary protection, reduces possible arbitrariness of decisions and encourages consistent decision making. It requires that sanitary and phytosanitary measures be applied for no other purpose than that of ensuring food safety and animal and plant health. In particular, the agreement clarifies which factors should be taken into account in the assessment of the risk involved. Measures to ensure food safety and to protect the health of animals and plants should be based as far as possible on the analysis and assessment of objective and accurate scientific data. Okay, so and a bunch of other information there that ensures you're not unjustifiably discriminating against other countries, particularly where there are similar circumstances or standards already in place to your own country. It cannot be above and beyond what an exporting country has already got in place if their health circumstances are the same as yours. So another really great website to come and to have a look at in due time. At the appropriate time when you are developing your input health standards. Okay. Right. So that's the end of the this particular module. In the next module, we're going to be looking at the variety of information, including some of the stuff we've looked at today on the website provided by New Zealand, Australia, the Codex requirements and information found under the OAE website, including the WAHID information, and how we actually utilise the information for developing import house standards, particularly when looking at the disease status of exporting countries, but also looking at where risk assessments have already been undertaken and how you can actually utilise the information for developing your own risk analysis program. So thank you, and hope you enjoyed it, and we'll see you next week.